Hi guys, I'm having a little play around with this again, and I'm doing this one for the benefit of Jamie and Georgia really, who weren't here for the session I did with Ben and Stephen in the last couple of days of term. This one is a way of finding a lower bound for the travelling salesperson problem. RMST stands for the residual minimum spanning tree, and the reconnectors is a kind of posh word for edges. I just want to point out that I can't get rid of that little man here, and I really dislike him. Okay, so what we need to do first, I've highlighted all of the edges that are incident to vertex A here. Ideally I'd delete them, but I couldn't figure out how to delete them. So I've highlighted them and I'm pretending that they're not actually there. What I'm going to do now is work out the minimum spanning tree of the edges and vertices which are left, hence the term residual minimum spanning tree. I'm going to use Cruscal to do this because I've got the network as opposed to a table where I'd probably prefer to use Prim. So I'm going to start off with the shortest route, which is F to C, which has a weight of 34. After that, I can see E to D, which is 39. C to D is 46. And B to E is 47. That actually gives us a minimum spanning tree. And the total weight of that is 166. Now what I have to do is actually somehow get A back into this spanning tree. So I've got my residual minimum spanning tree weight 166, but it doesn't include A. So I'm going to look at which edges are the smallest connecting A back in. So 43 over here and 37 here. So my reconnectors add up to 80. And in total, my lower bound is 246. So it's really important that you do the RMST and the reconnectors separate and don't just simply give a lower bound overall. You have to show the two numbers that you've added together. I hope that has been useful. Please be messaging on Show My Homework with any questions that you have on any of this.